Hi, my name is Jackson Rankin, and I thought I'd share with you some of the work I've been doing to um, study data analysis. Um, and I wanted to share with you some of my code that I've done. Um, there are a few lines of code, and Um, I use a lot of libraries. Glob will concatenate all of my data, and Pandas will allow me to process that data more effectively. NumPy will allow me to it essentially extends the mathematical capabilities of Python um, as it runs natively, and then matplotlib allows me to plot the data. And then SciPy, I import something called a CKD tree, which is a very powerful, very efficient data structure that I use for finding neighbors. And the data that I'm using is from a NASA mission called Gaia, and it's a mission that sort of catalogs a bunch of stars. And if let's say I ran this a little bit ago, and you can see that there are 2.02 million stars in this data set after cleaning, I mean. And I do some basic data analysis with pandas, which I think is, a little bit cheating. But I have statistical analysis on distance and tangential velocity and absolute magnitude. And distance is self-explanatory. Tangential velocity is, with respect to Earth, how fast is it moving that way? And absolute magnitude is a measurement of how bright a star is if we compared each star that we looked at equally. Um, like an example of this is like if you put a 100-watt light bulb at an arm's length, that's going to look a lot brighter than, maybe a candle at arm's length. Um, and again, I do some more basic data analysis, but I think the more interesting thing to look at here are the graphs that I've generated. This is by far the most visually striking graph that I generated, and I essentially take the coordinates of each star, right ascension and declination, which are, kind of like our latitude and longitude of of astronomy. And then I plotted the density um, using this is a two-dimensional histogram. So this would be a region of high star density. That is a very high, that is a region of very high star density. And this graph, sh shows me two things. That's our Milky Way. Um, that's the Milky Way galaxy. But you can see that there are also these sort of groove-like structures. Um, Kind of like, looking at a CD under a microscope. You'll see that there are these grooves in them. And how Gaia takes its data is it essentially takes a slice out of the sky and then processes it. And so I'm pretty sure that these slices, these grooves, are a consequence of, maybe Gaia wasn't taking as many slices as it should have, and or it could have been instrumentation failure, one of the two. Um, and anyway, let's move on to the next graph. This graph is a histogram of absolute magnitude. And this graph I find pretty interesting because there are two um, very visible peaks here. And one of these peaks could be main sequence stars, which are stars that are burning hydrogen. And then these could be like red giants or something, um, which are very bright helium burning stars. And I don't know. I found that pretty interesting. On this scale, magnitude, um, let's see, I think our sun has a magnitude of about negative 25. Um, and the dimmest object that you can see in with your naked eye is about a magnitude 6 or 7, depending on, viewing conditions of the night sky. And then magnitude of like -5 is about the apparent magnitude of Venus. Um, so again, Venus, and you can barely see it with your naked eye. The other graph that I found interesting, which is where the CKD tree comes in, was I took a sample of around 1,000 stars, exactly 1,000 stars, and I looked at each neighbor, and it turns out, each of those 1,000 stars has quite a lot of neighbors, and most of them can be found within, zero point zero 0.05 to zero point 0.1 degrees away from that star. But one thing to keep in mind here is that this is an optical measurement, meaning, um, a star could be really close here, but in reality, they're very far apart. I mean, even if they look really close, these are neighboring stars, but one could be much further away than the other. So, that was essentially my um, sort of experiment that I did with data analysis. And I thought, Gaia was a very interesting mission, and I got my hands on some data, which you can just find on NASA's website. Um, anyway, I hope you enjoyed, and thank you very much for watching.